In this video, I would like to talk about the asynchronous programming, so running an operation on a separate thread when we use Unity. In our game, we have an operation that takes a very long time and we run it on the main thread, which is controlling how we perceive our game. This is responsible for driving those robots and for me shooting. So let me go to the robot and I'm invoking the operation using the H key. And as you can see, everything was frozen for a while. Again, everything was frozen. And if you see in the console, it took 3 seconds to perform the operation. Let me show you the code that I'm using. So this is a simple perform calculation method that I use in the update. When I press H key, I am invoking a calculation. We loop through the to the array of float values and we assign mathf.𝗶 noise value to each of those to simulate, for example, if we were creating an infinite world and we were calculating the height map of our terrain. So what is going on in our game? Where our game is running on a main thread, which is responsible for showing the graphics of our game and all the stuff that the player can see. When we run our code that requires a lot of computational power and takes a long time to perform the operation, it is blocking the main thread so that our game cannot really be updated because all the resources available are taken by this method that we call. And only after the method is done, so we experience this freeze for about 3 seconds, we can resume our game and we can see that our game starts running. So instead of running our operation on the main thread, we want to do something else. We want to run our main thread with only our game in mind, and when we want to perform the operation, we want to introduce a new thread which will take care of performing this operation. So basically, when we want to perform the operation, we send the information from the main thread to start a new thread or to perform the operation on an existing thread. Nevertheless, we want to perform the operation on another thread and not on the main thread. So now our game can perform as it does, while the other thread is performing the same operation for the same time, so about 3 seconds, and only after it finishes, it should inform our thread that it has received or it has sent the information that we have requested back to it, so that now we can do something with those informations on our main thread. Now, the benefit of this approach will be that we can have our game playing as it should. It doesn't speed up the process, but it just unloads our main thread from performing this work that takes some time. Okay, so let's see how we would implement it in our Unity project. So a good idea to fix this issue would be to run this calculation on a separate thread and wait for the result until it is ready. Now in C# we have a task library that gives us a really easy access to asynchronous programming, so to starting a separate thread. The task class represents a single operation that does not return a value and that usually executes asynchronously. And we have those tasks objects that execute asynchronously on a thread pool, so on a separate thread rather than synchronously, meaning on the main thread of the application. And let's see the example here. So here is a quick example. Basically what we need to do is call our method and add to it a keyword async, and then when we want to run our code, we wrap it in the task.run and we use the lambda expression. If you are not familiar with the lambda expression, you can check out my other tutorial about it. The link should be in the top right corner of the video. And we call await keyword so that we await the result before we continue with the rest of this method, which is here empty. Okay, I'm in the async test script and I would like to modify the perform calculation method to be run asynchronously. So I'm going to copy it, I'm going to paste it below, and I'm going to rename it to be perform calculation async. First of all, we need to add the async keyword before the name of the method. So I will call async. Okay. Now it is showing me that the async method lacks await operator. So the await operator is when we want to await an execution of some code. So this is our code that we want to await. Basically this code. So what I will want to do is call var result will be equal to task, and we do not have it, so right click, quick actions, and we need to be using system.threading.tasks library. It will be imported at the top, and I have this using debug equals debug engine.debug because I'm using the system.diagnostics to measure the time of the execution of this using the stopwatch, so that we know how much time it took to perform this operation. In any case, we have this task, we need to add a .run, and this will run the code that we pass here as the action delegate. Again, check out the other video to understand what are delegates. And we are going to pass here this code, so it will be executed on a separate thread. So we are going to create a lambda expression. We are not going to take anything, equal sign and greater sign, so this is the lambda expression. So we do not take anything, and we want to perform this body of a method that we are going to pass here. So all we need to do is cut our current code that blocks our main thread and pass it to our run lambda expression. Okay, so this is our code. Now, as you can see, we have this map values that we calculate, so I will want to return it. So I just add return, and I will call the map values. Okay, but that's not everything. This would simply run this task and continue invoking this code below. So if I save it, and if I call this code inside our get key in the update, you will see that we save it. Let's go back to Unity. Okay, I will play the game, and you will see that if I press H, the operation took 0 milliseconds. So this is amazing. Well, not exactly, because we were not awaiting our thread, so the thread was performing its operation and we never received the values from it. So we are calling this an async operation, but in reality we are never awaiting the result of our thread, so this result is never filled. So what we will need to do is add await before we call the task.run. And now this operation will be performed, and only when it completes and returns this map values, we will perform this operation here. So additionally, what we could do is call debug.log, and since our task, if we drag our mouse over it, will return a task of float to the array, we can call debug.log, we can call size of to the array, and let's add to it our result dot get length 0, and we are going to add plus result get length 1. Okay, so now only when the task has finished running on a separate thread and returned our map values, we are going to call those two debug.log statements. And again, it will only work if we have our method with the prefix async added, or keyword async added before the name of the method, so in its definition. Okay, so let's go back to Unity. Okay, let me press play, and now we can move and shoot, and if I press H, we have the message H was pressed, we can still move and shoot, and after some time we are receiving the data. So size of the 2D array is 10,000, and as you can see in our async test, the data, the size of the data is set to be 10,000, so it is the correct size returned by our thread. And now I can go further, find our enemy and press H to load the data, and it is all working fine. And after some time I'm receiving the data from our separate thread. So that's basically how you would run your operation asynchronously to unblock the main thread, so you can perform some calculations or data creation or procedural generation on a separate thread. Now, one more important thing about our threads is that they run and they are not stopped by our Unity play or pause button. So if you press play, now I'm going to press H to calculate our data, I'm going to escape and stop the game, and as you can see it still has printed our result. So let me show you again. I'm going to press escape now to be able to use mouse. I'm going to press H and exit the game. And as you can see, we are not playing, but still our thread is printing the data. So this is a bit problematic because we now cannot stop our work on the threads when we stop our Unity. So how can we deal with that? So again, let's take a look at the documentation, and task cancellation needs to have something called cancellation token source. So let's implement it in our code and let's see how we can stop our code from performing the operation on a separate thread using this cancellation token source. Okay, so I will create a variable at the top in our class, cancellation token source. Again, we need to use right-click quick actions, and we should have the cancellation token source using system.threading, and let's call it token source. Okay, and let's create it in our start method. So let's call start, and we are going to call token source equals new cancellation token source. Now we need to pass this token source, or rather its token, to our task. So after we call our task.run, as the second parameter, we can pass the cancellation token. So let's call token source.token, and this is passed now as the parameter to our thread. Now to use it, I will call here, when we are looping through this for each loop, if our token source dot is cancellation requested, what we can do is simply return our map values, for example. And again, let's copy this code, and when we finish this task, we are awaiting it. If this is called, we can simply return from this method and not perform the further code down the line. So now last thing is, how can we call this token source to be cancelled? What we can do is call our onDisable, for example, and onDisable we can call our token source.cancel, and this should cancel the task that we have run on our separate thread. So maybe let's debug.log and a message that we have stopped, so task stopped, before we return from this method. And now if we go to Unity, okay, I'm going to press play. Again, press escape so that I have mouse ready. I'm going to press H, stop the game, and as you can see, the task was stopped. So now we have a safe way to stop our asynchronous operation if we desire to, if we do not want to wait, or if we are simply debugging the code. Now, in the next video, I would like to explore the topic of running things in parallel and using the Unity jobs system versus using the parallel library from the task library from the C# language. And that's what we are going to talk on in the next video. Until then, leave a like, subscribe, and I will see you in the next video. And if you want to support the channel, you can do it by joining the Patreon. The link will be in the description. Take care!